Hello students, in this video there is a problem that we need to solve where this I0 is the unknown and to calculate I0 it is not mentioned which method we have to follow, but if we see there are current sources available here, so it is better to use nodal analysis. But we also know if we are applying nodal, what we would get is voltages at unknown nodes, or you can say what we can calculate is voltage at non-reference nodes. So if we see in the given circuit, this node is my reference node, that is 0, and then further there are 1, 2 and 3. There are 3 nodes. So if I am using nodal analysis, I can get V1, V2 and V3. And if I know what is V1, I can say I0 is simply V1 minus 0 upon 8, or I0 is V1 by 8. And since I am not concerned about V2 and V3, so there is no need to solve for the values of V1 and V2. So that is what my aim would be in this particular solution. I would be looking for equations first of all, 3 equations, 3 unknowns, and out of that I would calculate V1. Then I would use this simple formula that the current across any resistor is V by R. So let us start with the solution. So if we come at node number 1, and before we start with you can say nodal analysis, let us assign random directions to the branches where current is not specific. So at node 1, if you see at this node, this current is leaving, and this current is also leaving, and this current is also leaving. So all 3 currents are leaving a node. So I can simply write I1 plus 4 plus I0 is equal to 0. So let us transform this into V by R form. So it would be V1 minus V3 upon 1 plus 4 plus V1 by 8 equal to 0. So this is my first equation. Now at node 2, so let us come at node number 2. So what should we get at node number 2? So here this current is entering and other currents are leaving. So I can write the current that is entering is 4 and the currents that are leaving is I2 and 2I0. So let us again transform this. My I2 is V2 upon 2. It is V2 upon 2. And what is my 2I0? It is 2, and I0 we have seen here also. I0 is V1 by 8. So I should put this value here, that is V1 by 8. So these are my 2 equations. Now let us concentrate on node number 3. At node number 3, if we see again, 2I0 is entering a branch, entering a node. Similarly, this I1 coming from here is again entering a node, and I3 is leaving. So I can say 2I0 plus I1 is equal to I3. Okay, as it is visible here, this current is entering, this current is also entering from here, and I3 is leaving. So accordingly we have written the equation. So we can write my I0 is V1 by 8, my I1 is V1 minus V3 upon 1, and your I3 is V3 upon 4. So if we see, we are having 3 equations and we are having 3 unknowns, so we should be able to solve it. And if you are solving it with the determinate method also, so what you would be getting is something like this as coefficients while you will solve it. This is while you will solve this, while you will be solving equation 1, 2 and 3. And since I am concerned about only V1, I need only V1, so I can say V1 is delta 1 by delta. So if you calculate delta 1 here, it would be 32 into 40. And if you will calculate delta, that would be minus 40. So your V1 would be minus of 32 volts. You can solve it by yourself. So while you calculate V1, since I know now what is my voltage at V1, now this node voltage I know is minus 32 volts. So I can say, therefore I0 is equal to V1 minus 0 upon 8, that is minus 32 volts upon 8. So I can say I0 is 4 amperes, that is negative. So minus 4 ampere is the current that would be passing through this particular branch. So I hope things are clear to you. If you are having some doubts, do comment me in the comment section, and I will see you in the next video. Till then, have a nice day. Thank you all.